What's up, CoderBite? Welcome back to another data structures and algorithms video. I'm Elizabeth, and this week I have a black eye. Now, you might be wondering, why are you filming a video, Elizabeth? And I have two answers for you. Number one, I think this is going to take a while to fade, so I wanted to make sure that I made something for you guys anyway. But the second reason is because I think there's a lesson to be learned here, and I hate when people say that, so please forgive me. I got this while learning how to skateboard. Now, if you're wondering why I'm learning how to skateboard as an adult, you can join my mom, who is also wondering the same thing. But the answer is I really use learning new skills as an opportunity to prove to myself that I can do it. And I think that when learning any skill, it's a really important conversation you have to have with yourself, that you can do it, even if the learning actually looks a little bit rough, right? All learning doesn't happen in a straight line upwards. It's often filled with peaks and valleys, and persist because it's worth it. Anyway, so enough about that. Congratulate yourself for showing up today for this video. We're going to continue the conversation all about dynamic arrays. This week's problem is actually going to be around strings, and I want to just point out that often arrays and strings, interview problems related to arrays and strings are grouped together, because you can think of a string as an array where every character is like an index of the array. So anyway, without further ado, let's jump into this week's problem. I really like this week's problem. I think that you can, ask it to your non-technical friends, and it's one of those problems that it's kind of like a brain teaser. I think you can solve it without any coding knowledge at all. So yeah, let's do this. Okay, enough lessons for today. Let's jump into this week's problem. Given a string, write a function to check if it is a permutation of a palindrome. So what is a palindrome? In case you don't remember from elementary school, a palindrome is that special kind of word that is the same forwards as it is backwards, which is kind of fun, right? So here are some examples of some palindromes. We have level, obviously the same forwards and backwards. Hannah, rotator, my gym, no melon, no lemon. Was it a cat I saw? So the first thing I want you to notice is that these are all palindromes despite punctuation and spaces, right? So we're just ignoring all of that, and we're just thinking about the letters here. So when you read these forwards and backwards, again, it's the same, right? The letters are in the same order. There's the same amount of them. That's a hint to how we're going to solve this algorithm. So what is a permutation of a palindrome? Well, here are some permutations of the palindromes above. So these are just the same words, right? And I've rearranged the letters so that it's not the same forward and backwards, but it's a permutation of a palindrome, right? So our function has to take a string of random letters like this and determine, could we arrange these letters in such a way that they would be the same forwards and backwards? So I think as far as an approach goes for this kind of problem, it's a really good idea to kind of ask yourself, what are the different traits of what they're talking about, right? What are some of the things that make a word a palindrome versus not a palindrome? And what traits of those are still true even if it's a permutation of a palindrome and not a straight palindrome? So what do I mean? So one of the traits of a palindrome is, again, that the letters are the same forwards and backwards, right? The order is the same from beginning to end as it is from end to beginning. That's not still true if it's a permutation of a palindrome. So what's another characteristic that we can potentially, notice that stays true even if it's a permutation of a palindrome and the letters have been, mixed up in a different order? So I think for this one, the important thing to notice is that for a palindrome to be the same forwards and backwards, what that really means is that there is an even number of each letter, except for potentially one that has an odd letter, which would be the middle point, right? Because a palindrome, when you divide it into two, it has to be the same in the first half as it is as the second half, which is almost the definition of an even distribution of something, right? Around a middle point. So let's take some examples just to, illustrate this point. So here's a palindrome, no melon, no lemon, right? And we can just add in that arbitrary middle. Well, it's not arbitrary. This is the middle of the string, right? 1, 2, 3, 4, 5, 6, 7 letters on this side, and 1, 2, 3, 4, 5, 6, 7 letters on this side. So this is the middle of this string. Now, if you look at the distribution of the letters, we can see here that there are 4 N's, right? 1, 2, 3, 4. There are 4 O's, 1, 2, 3, 4. There are 2 M's, 1, 2, etc., right? Because there has to be everything on this side has to have a pair that is on the other side. That's the definition. And this is true for a palindrome with an odd number of letters as well. Let's look at that. So here's rotator, right? And we can add our middle point, which is in the middle of that A. And we can see with the distribution of the letters, there are 2 R's, there are 2 O's, there are 2 T's, and there's only one odd, letter frequency, which is that A, which is the middle point. So we can, from this, we can prove and say, hey, it's definitely a palindrome if there is an even number of all the letters, except for 0 or 1 of an odd frequency of a letter, right? You're allowed to have one letter that has an odd frequency, the rest have to be even. And that is true even for permutations of a palindrome, right? Because even though the letters are mixed up in a different order, if we're checking frequencies, there is a way to organize them in such a way that there is the same letters on the first half as there are in the second half. So let's look at an example of a permutation of a palindrome. So, this is just saying this will continue to be true for permutations of a palindrome. It's true for palindromes and permutations of palindromes. So here's a bunch of mixed up letters, which is no melon, no lemon, all mixed up. So this is a permutation of this palindrome right here. So let's take a look at those frequencies again. So there are 4 N's, 1, 2, 3, 4, 4 O's, 1, 2, 3, 4, etc., right? So our algorithm is as such. We're going to check the frequencies of the letters, and if there is an even number of all letters, except for just one that's allowed to be odd, then it's a permutation of a palindrome. And if not, return false. Let's code this out. Okay, so by now you all know the drill. Here I have my Visual Studio Code editor, and here are some test cases that I've already filled in. So here we're checking level. Is that a permutation of a palindrome? Yes, it is. Here's a permutation of that no melon, no lemon, I think, palindrome. This is a permutation of that, of course, and it also should return true. Here's another one that should return true. Here's another one that should return true. And then here are 2 that should return false. Elizabeth and Becky are obviously not palindromes. Okay, so let's get started. We can declare our function. And let's call it permutation of palindrome checker. I think that's a decent function name. And this is going to take a string, right? So far, so good. This is extraordinarily simple. The first thing we're going to want to do while we're looping over the letters is we're going to want to check, is this character actually a letter, right? Or is it a white space or a question mark or an exclamation mark or anything other than a letter? So I think what I want to do is make a helper function, and that will serve as something easily callable that we can call on each character just to make sure we're only dealing with the letters. So let's declare that up here. We can call this is character a letter. That's pretty descriptive, right? And that's going to take a character. We'll call that charm. So I think I'm going to use regex for this just because it's pretty simple, straightforward, easy to read. And a regex to check whether something is a character is pretty simple. So we're going to put that between those 2 forward slashes, and then I think we're going to use brackets, which in regex denotes that it's a character class. So we want to know if a character matches anything in a range of what we're going to pass in here. So for letters, I think we want to check whether it is A to Z, right? Or we want to check if it's capital A to capital Z. Those are all of the things we want to include. Anything else, don't include it. And then what we can do is we can just, right, we can wrap that in a parentheses and we can call the test method. And the test method will test whether there's a match in the string that we pass it. So we're going to pass it the char. And it's just going to return a Boolean whether or not if the regex found anything, something that matched the pattern or not. So I think that should be good. We can test that out, but hopefully that works. And go back to our actual main function here. So just to reiterate the algorithm that we're writing here, we're basically capturing the frequencies of the letters in the string, and then we're going to go loop over that and make sure that they're all evens except for at most one odd frequency, right? So what we can do here is we can say maybe const letter frequency, right? So this is going to be our frequency tracker, and we can set that equal to an object. And then we can just start to loop over our string, right? So I'm going to use a for loop for that. String.length. And remember, this is in the dynamic arrays series here on CoderByte. And it's important to notice the similarities between array problems and string problems, because at least here in this case, and in many cases, it's almost interchangeable how we're operating on the strings and or arrays. So that's just something to note. But here we're looping through that string. And the first thing we want to do is we want to check, is this character even one that we care about? Is it a letter? So let's do that. We'll call is character a letter, and we'll pass it the string at I, right? So that will be the letter. And we only want to do things if it is in fact a letter, right? Okay, so at this point in the loop, we've checked that it's a letter. It is, in fact. And so what we want to do is we want to normalize a little bit, right? Because we don't want to know whether there were one uppercase A and one lowercase a. We want to know that there were two A's. So I think the first thing I'm going to do is I'm going to capture the lowercase of any letter. So despite the fact that we're checking for uppercase and lowercases here, we could have, of course, first called lowercase on it and then passed it in here with just lowercases. But this way, I don't know, this just makes more sense to me in my mind. So I'm going to say that the const lowercase letter is the string at I dot to lowercase. And then essentially what we want to do is we want to track the frequencies, right? So I'm going to say that the letter frequency at that lowercase letter, we're going to set it to whatever's there already, right? Just in case we've already logged a frequency, or 0, right? So that what that does is we just initialize it as 0 if this doesn't exist yet. Okay, so at this point, all we have to do is just increment, right? So we're going to say that the letter frequency at that lowercase letter plus. Okay, cool. Okay, so at this point, we now have our frequencies. We're tracking our frequencies of all of the letters, and that's all we're doing so far, right? So what is left? We now need to loop over those frequencies and make sure that there's, in fact, only at most one odd frequency, right? So for this, I'm going to say that we're definitely going to loop over that letter frequency object, right? So let's say for const letter in letter frequency. Now that letter is going to be the key in that object, and then letter frequency at the letter is going to be the actual number of how many times that letter has appeared in the string. So what we want to do here, right, is we want to check, is it odd? And how do we check if that frequency is odd? How do we check if a number is odd in JavaScript? Generally, you can use the modulo, which is just the %, And what that does is it will divide, right, whatever the first number is. So let's say 8, right? 8 mod 2. So what that would equal would be 8 divided by 2, which is 4. And then it will return the remainder. So that will be 0, right? So if we did 3, it would be 8 divided by 3. So that 3 goes into 8 2 times, right? And it has a remainder of 2. Maybe that's confusing because it was the same answer, right? How many times 3 went in and what the remainder was. But let's say 5, right? So 5 goes into 8 one time, and this would be 3. So if you haven't used that before, that makes sense. I've literally never used it in actual programming, but in coding interviews, sometimes it comes up. So it's a good one to know. Okay, so what we can do here is we can check whether that letter frequency at that letter, right, mod 2, which is, does 2 go into this number? Can we divide by 2? If it's not equal to 0, then it's odd, right? So any even number mod 2 will be 0 because 2 will go into it an even number of times. There will be no remainder. If there's a remainder, we know it's odd. Okay, so hopefully that makes sense. So we have our, right? So, okay, so now we don't want to check if there's any odd frequencies, right? Because we're allowed to have just one odd frequency. So we can't just immediately return false here. We actually have to keep track of whether we found one yet or not. So I'm going to call that let has odd frequency, has odd, maybe letter frequency. And I'm going to say that's false, right? We haven't found one yet. So if it's odd, right? So this is odd frequency. If it's odd, we then have to do another check, right? We have to say, have we found one yet, right? So if we haven't, right? If has odd letter frequency is still false, then we set it equal to true, right? Because that means this is the first odd frequency and that's okay. If we have, right, so it's an odd frequency and we've already had an odd frequency, then we can return false, right? This is our second odd frequency, and as soon as there's 2, we don't have to continue checking, right? It's definitely, we're done. Okay, so we've taken care of all of that, and I think the last piece of this is just to return true at the end, right? So if we've gone through the entire letter frequency object and we've never hit this, then we're good. So let's see what we get here when we run this. I'll pull up our test cases so we can see it. All right. And we get false for all of them. That is a great sign. Okay, so what have I done wrong? So let's see if I can debug this and see where we've gone wrong. Okay, I'm checking letter at letter frequency here, so that's definitely not right. Okay, let's try that one more time. All right, and we get true, 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 false, false. Okay, so we're good. Now, this is a great solution, right? Definitely, I think it's pretty it's clear, it's straightforward, it works in terms of memory. You're just checking, you're using an object and you are storing integers at the values of the keys, right? So can we make it better? I don't know that we can make it better, but we can definitely do something different to impress our interviewer. And this is a really important point in general, that sometimes people make code more confusing and it's more confusing and it's not necessarily better code. So I think that just think about that before you go ahead with a solution and understand, what's my purpose here? Why am I changing things? Is it better? No, it's just different. and it's slightly more confusing, maybe, but it's cooler and it's a cool, talking point in an interview. So I'll show you this solution, which we can do now, but I just want you to have that in mind. So here we're tracking frequencies at each for each letter, right? Now, what if we, instead of tracked frequencies, we put something in those value, in the value of the letter tracker object, that was just like a switch, like an on-off switch, right? What if we had it be just a Boolean, and every time we found a letter, we turned the switch on, and every time we found a letter again, we turned the switch off, etc., etc.? What would happen? If we turned the switch on and off an even number of times, then the switch will be in the same position that it started in, right? Think about it. If you turn a light on and off, you flipped it 2 times. If you turn it on, off, on, you flipped it 3 times, and it started in the off position, and now it's in the on position. So we can do the same thing here. And instead of checking whether there's an integer that's even or odd, we can just check that every single switch is in the same position that it started in, except for one, which is allowed to be in a different position. So again, not necessarily a better solution, but in my opinion, it's a cooler solution. It's kind of fun. But yeah, let's do the code for that right here. So I'm going to say, we can say, often when I do 2 different versions of a function for whatever reason, all I do is just add like an _1, and then I just write it again. And then I don't have to update my test cases with different names. I can just update the function, right? Whichever one I want to run, I flip it to the one that is in the test cases. So that's just food for thought. But okay, so here we have permutation of a palindrome, right? So we have function permutation of a palindrome, and that's going to take a string, and we're basically going to do the same thing, right? But I'm gonna call things different. I'm gonna call things different names because they're tracking slightly different things. So I'm going to say const letter switches instead of letter frequencies, and I'm going to, instead of making it an object, I'm going to make it a map, just for fun. So let's say it's a map, right? So a map is like an object. There are a few differences between them. I suggest you look at MDN for that. But a map is cool because it has some cool methods and ways of accessing the properties. Like it has a .has, .get, .set. So that's kind of fun. Okay, so we have our letter switches, right? And we're going to do the same thing. We're going to loop over the string. So let I equal to 0, I is less than string.length, I plus plus. Okay, so we're looping over our string, and we still want to check if it's a letter or not, right? If the character is a letter. So if is character a letter, and then we can say string at I, only continue if it is a letter. And that way we will skip all of those spaces and other, question marks, whatever. Okay, so we have our is character a letter checker. And the first thing we want to do is, again, the same. We want to take that lowercase version of the letter. So let's say, I think I can use const here, const lowercase letter equal to the string at I dot to lowercase. Okay, so now we have our lowercase letter. So the first thing we want to do is we want to initialize that switch, right? We want to say, okay, the switch is on or off. It really doesn't matter. It just has to be the same. We have to remember which way we initialized it. So I'm going to say if that letter switches, right, .has that lowercase letter, and again, I can use that .has as like checking a key, whether or not that key exists, which is useful because I'm probably going to be using Booleans to toggle the switches, right? So instead of checking whether it exists like we did above, it would fail if it was set to false. This we can check, does the key exist in the map? So that's very useful in this particular case. Okay, so if the letter switches does not have that key yet, right, we want to initialize the switch. So I think we're going to initialize it as true to start. I don't know, that seems like nice to me that we're starting things in, I guess we're starting in an on state, and like light switches are off initially, maybe. I don't know, whatever. I'm going with it. So we're going to initialize the switch just by saying letter switches dot set, and then we can set that lowercase letter. And then the second parameter to this is what we're setting it as. So we're setting it to true. Okay. Now we've come across it, right? So because we've found a letter, we're going to flip the switch, even if it hasn't been like added in the switches tracker yet. We're going to flip it regardless because we have stumbled upon a letter and we need to show that we've been here. So we can do that here. So this is going to happen whether or not we've already seen this switch. We're flipping it. Every time you see a letter, you flip the switch. Okay, so letter switches, right? We want to use .set again. And what we want to do is we want to toggle it, right? So because we're using Booleans, and this is JavaScript, we can just, bang whatever the value is, right? And that will opposite it or whatever. So let's say bang letter switches dot get lowercase letter. So that will just take whatever's there and toggle it, right? It will do the opposite. Okay, cool. So that's actually all we have to do there, right? So now every time we come across a letter, we will flip that switch. And what we want to check now is that everything is still true, except for at most one can be false, right? Because if we've hit a letter once, it will be false. And so we have to hit it again to be true, and that will be even. Or we can do it again and again, right? So that's how we've come to this assumption here that if it's a permutation of a palindrome, all of the letters, all the switches will be back to their original starting point, which is going to be true. Okay, so this is again going to be very similar to before, right? What we're going to do is we're going to first, we need to track whether or not we found one, right? So this is going to be let's say found switch not in original position. So we haven't found one yet. And then what I think I want to do here is I think I'm going to use a function, a method that's an array method called every. Now, every, if you haven't used it before, will return true if everything is a predicate, right? A predicate is the function that you would pass to this sort of function if it returns true for every single element in the array. So what we can do here, and the reason why I'm using every and not just a loop of some sort, is because an every can break right away, right? As soon as we find one that the case is bad, we'll just break. And every is a nice way of short-circuiting the rest of the loop. So I just wanted to show that that can be done, so we can do that here. So what we have to do here is actually, I think what we're going to do is we're going to take the letter switches and we're going to take its keys. And the keys will all be just the letters, right? And what we want to do is we want to make this an array. So this is actually going to be an iterable, and every is not a method on an iterable. So this is keys being a method on the math object. So I'm going to use the spread operator to spread everything that is returned from this iterable into this array. And what we're going to do here now is we're going to call every on that. And why are you giving me, because you can't just in JavaScript, you can't just have an array defined like this. So what we're actually going to do is every will return true or false if the, predicate actually does return true or false for everything. So we can actually just return whatever the every returns here, because that will be the answer to whether or not this is a permutation of a palindrome. I hope you're following. Hopefully it will become more clear as we, walk through the example. But I just wanted to I wanted to show you guys something cool and new here in case you haven't seen anything like this. Okay, so here we have every, and we have to talk about, the function, the callback function that we're giving it. So every is going to get now, that is going to be every letter, right? Because we've now made an array of the keys, and the keys of our letter switches are the letters, right? So we can just make a nice arrow function. And what we want to do again, I want to, make it clear here, is we want to check that everything is in its original position. So check that all the switches are in the true position, except for at most one, right? So that is going to be tracked with this. If this is ever true and we find another one, we know we're in bad shape. It's not a palindrome or a permutation of a palindrome. Okay, so first let's just, because we only have the keys, right? We only have the letters. So let's pull out what the switch position is, right? So that's just going to be the letter switches at that letter, right? Oh, and that's not how you get it. You get it like that because it's a map. Okay, perfect. And now what we want to do is we want to say if the switch position is not in the position it started. And so here, because it's a Boolean, we can literally just check, right, if switch position, because that will be if it's false. Now, if it's false, if we've already found one, right, we can return false immediately. Otherwise, we can just set it equal to true, right? So that will be, if it gets here, that's because it's the first odd instance. It's the first position that's not in the same position as it started. If we're here, we've already found one that wasn't in the position it started in, so we can return false. Okay, so that is that. And then because we have to, for every, we have to return true. If it doesn't get into there, then we're good, right? So we can just return true. So that should do it. And I believe that, yeah, I think that's it. So let's pull up our test cases and let's see what we get here. And yeah, we get true, 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 false, and false. And I want to make sure you guys see, I want to console log out what we have here. So let's say console.log the letter switches. I'm going to say console.log string. So let's look at what we have here. So this is after we've flipped all the switches, remember? So we see that for level, we have true and true, right? We have two switches that are maintained in the same position, and then we have one that is flipped up or down, whatever, it doesn't matter. But that's okay because we're allowed to have one. For lemon, we have, or no melon, no lemon, they're all true, right? For this one, maybe this is, was it a cat I saw? All the switches are in their original starting position except for one, which is also okay, right? Same for Hannah. And then here we have Elizabeth, where the only letter that appears an even number of times is the E. Everything else, it only appears once, which is definitely not a palindrome. So all of those switches got flipped up or down, again, whatever. And the same with Becky. And so that's how we make that determination whether or not the letter frequencies are in fact all even except for at most one. Thanks for joining me again for another data structures and algorithms video. Make sure to keep your eyes out for the next video in our dynamic arrays series. And remember, when learning something new, sometimes you're going to look like this, and some days you're going to really shred. Have a good one, guys. See you later.